Okay, good day. This is Math 140, College Algebra. I'm Professor McCulley. This is lesson 2.3, add, subtract, multiply, divide, and compose functions. Let's get right to it. So today we are going to add, subtract, multiply, divide functions, and then we're going to find the composition of two functions. We're going to use and apply the composition of two functions. So what does that all mean? So the combination of functions rules. Given that f and g are functions with overlapping domains, the following combinations of functions are defined as follows. So the sum or difference f plus g of x is just taking the function that is f and the function that is g and adding them. The product of two functions, f g of x, is just the product of f of x and g of x, and then the quotient or the division of f over g of x is just going to be f of x over g of x, provided that g of x is not equal to 0, and you can't have a division by 0. So some quick examples: if f of x is 2x plus 1 and g of x is x squared minus 1, if they ask us to find f plus g of x, all we're going to do there for that one is we're going to take f of x, which is 2x minus 1, and then to that we're going to add x squared minus 1, and we're just going to collect. Oh, I can't spell. Let's see if we can do a better job. X squared minus 1, we're going to collect like terms. And so x squared is a term unto itself, so x squared, and then I get 2x, and then negative 1 and negative 1 would be negative 2, and that is going to be my final answer for that one. And then g minus f of x means that I'm going to take g of x, which is x squared minus 1, and then I'm going to subtract away the whole value that is f of x, so 2x minus 1 there in parentheses, and then I need to distribute the negative. And because this is, I'm subtracting away this whole thing, I need to distribute the negative to both terms. That'll give me x squared minus 1 minus 2x and then plus 1. And so now I'm going to collect like terms. And so x squared is the only term of that value. And then I get a negative 2x, and then negative 1 plus 1 is 0. So that is going to be my final answer for that one. And then f or g f of x, I'm going to take g, which again was x squared minus 1, and I'm going to multiply f, which was 2x minus 1. And so now again I have to distribute. So x squared times 2x is 2x to the third. X squared times negative 1 is negative x squared. Negative 1 times negative 2x is negative 2x, and then negative 1 times negative 1 is positive 1. There are no like terms to collect, so we are good right there. The composition of functions, the composition of function f with the composition, let's start over. The composition of function f with the function g is defined as f with a little raised circle, g of x, which basically means this. I am going to take the function that is g and I'm going to plug it in for f, and that's what I'm going to do. The domain of f composed of g of x is the set of all x in the domain of g such that g is in the domain of f. And so basically what I'm doing is I'm plugging in all of the domain that is in g into the function, and then everything that comes out that is also in the domain of f is now in that domain. So if I'm given again f of x is 2x minus 1, and then g of x is x squared minus 1. We're going to compose f with g of x and g with f of x. Now, in multiplication of real numbers, the order of multiplication is not important. That's because multiplication is commutative. I can go 2 times 3 and get 6, and I can go 3 times 2 and get 6. With composition, we're going to see that composition is not commutative, and so order is going to be important when you're composing functions. So f composed with g of x is just f of g of x. And so g of x is defined as x squared minus 1. So I am taking that f and I am plugging in x squared minus 1 into f of x. All right. So if I said, and this is kind of an off to the side example, so let me write this off to the side in red. If I said find f of 2, you would say, all right, I'm going to take a 2 and I'm going to plug it in for x, and then I'm going to simplify. Well, here we're not plugging in a number, we're plugging in an expression. So it's 2 times something, that's what f of x is, minus 1. And that something is what's in these parentheses. So x squared minus 1, that'll give, and I need to distribute, so I've got 2x squared minus 2 minus 1, and then I need to collect these like terms. So I've got x squared, or 2x squared minus 3, and then that is my final answer because I can't simplify any further. Now, if I wanted to compose in the other direction, and I wanted to compose g composed with f of x, that means I'm going to take g and I'm going to plug the function f of x in for g. All right, now f of x is defined as 2x minus 1, and g is defined as something squared minus 1. I get it from here. That something is this expression 2x minus 1, so 2x minus 1. Now for me to simplify that, I have to square this thing, and please don't tell me that it's 4x squared minus 1, because you cannot distribute exponents across this subtraction. So I have to multiply that out. 2x minus 1 times 2x minus 1 minus 1. And so I get 2x times 2x is 4x squared. I get minus 2x. I get another minus 2x. And then I get a plus 1. And then I have to bring down this minus 1. And so I end up with 4x squared. And then it's minus 4x. And then plus 1 minus 1 is 0. So that is my expression right there. All right, so my final example here. Mr. McCulley needs 4 wild widget parts for each of his widgets. Then he sells the widgets for $3 each. Write an equation for the number of widgets as a function of the wild widget parts P. So I need 4 parts for each one widget. And so if I'm writing that, if I go, what did I say? W as a function of the number of parts. So W as a function of the number of parts. I have my P there. And so for every 4 parts, I get 1 widget. That means I need 1/4 of a P gives me a widget. So I need 4 parts will give me 1 widget. 4 times a fourth gives me 1. 8 parts for 2 widgets. So if I go 8 times 1/4, I get 2. And then part B says, right, the revenue is a function of the number of widgets sold W, so R as a function of W. For each widget that I have, I get $3. And so that's really all that I have there. And then for part C, it says compose R with W. So R, and this should be an R, I apologize. It says R is a function of W, so R is a function of W there. So R composed with W, it should be a capital W, would be, and then R of W of P, and I guess I don't need those outer parentheses, so let's get rid of those. There we go. And then we already said W of P is going to be 1/4, so I've got R of 1/4 P, and then R was 3W, so 3, and then wherever I see a W, I'm going to replace that with 1/4 P, and that'll give me 3/4 P. And then, so that's going to actually be my final answer. So R composed with W of P will be 3/4 P. That's my final answer right there. And then part D says describe the new function from part C as a function and what it calculates. And so what I get here is this is a revenue function determined by the number of parts. So R composed with W of P calculates the revenue as a function of the number of wild parts as a function. Oh, I already did that. The function of wild parts. And so we can also conclude that we can expect to earn EARN 3/4 of a dollar for every wild part. Well, that's all I got for today, folks. So today's Marvel Fun Fact of the Day: after the success of True Lies, James Cameron was trying to get a version of Spider-Man created, but the company he was working with went bankrupt, and so he quote unquote settled and made a different movie called The Titanic. And that kind of worked out for him fairly well. But we missed out on a James Cameron Spider-Man. So that's all I got for today, folks. Have a good one. Bye.